Good evening, kids. Today's class, we are going to discuss about the Pulley constraints in the laws of motion chapter. Let me start with the question. In the setup shown, blocks of mass m, 3m, 4m. So here this is m, 3m, 4m. They are placed on a smooth frictionless surface. The surface is frictionless, horizontal surface. The free end P of the thread is being pulled by a constant force. Sorry, there's a free end of the thread. It is pulled by a constant force 2F. We have to calculate the acceleration of this particular point. So this will be our free end. We have to calculate acceleration of this point. This is being pulled by a force 2F here. Okay, these are related to pulley constraints. And if you check the Jee Advanced, we do have some questions based on pulley constraints. So definitely all possibility of asking may not be very lengthy. A simple basics pulley constraints can also be stressed. Okay, we'll start from here. So we'll measure the displacement. So let me define them. Let me call this as block A. Let this be block B. Let this be C. This is a pulley P as usual. So we'll define all their positions from some reference point. The reference point, let me choose here. We can choose anywhere. So let me choose here. This will be easy for us. You better call this as an origin. Then the position of all these will define the displacement of pulley will be displacement of this. So let me define this as xp. xp. Displacement of pulley or block, both are same. The displacement of block C and this particular pulley will be same because this length of the string will not change. So the displacement of this pulley and these two pulleys, the displacement of these two pulleys and this block C will be same as they're connected by an inextensible string. So therefore now we'll define this as xc. Either you can define this, you can write xc till here or till this pulley. It will be same. Define. Next we'll define one more. Define the block here. We'll call this as block here. Till here, this one xc. Then we'll define the xb. Okay, fine. Now the displacement of these pulley and the block will be same. So either you measure xb from here or here, it will be same. Fine. Now let me take this some arbitrary pulleys there. There's one arbitrary pulley is there. We'll call this as a XABC. I'll call O. Will actually may not be needed. You call this as pulley O, that one. They're the one. All these are movable pulleys. Now we have to find out the constraint equation. So overall length of the strings, overall this length of the string, you see that all the total length of the string remains constant. This total length of the string will remain constant. Fine. Then afterwards, the length of the strings which will not change those things will indicate by some other color. Will indicate by some specific color. Let me show it. This length will not change. 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 And this length will not change. Okay, agree. This length of these this yellow color strings length will not change. I'll indicate here. Yellow colored segments will not. These are some very simplified, which will help us a lot. Now we'll define all one by one. I'll start from we'll write down the equation. So this length is how much will be x4 minus xc. This length will be x4 minus x4 minus xc. I'll write down the equation now. Let me write down the equation. X4 minus xc. This particular thing, this length should be xp minus xc. Okay, agreed. Then this length we have to define. This length will be this length. This will be xb. This will be xc. So this length will be xb minus xc. So there's no concept, just an observation. Because when you pull this particular pulley, when you pull the free end P with a force 2F, this pulley will undergo displacement, block B will move, block A will move, block C will move. Now, next question comes in what direction they'll be moving. So they'll be moving here like the acceleration of block B will be like this, acceleration of block A, then acceleration of block C. These are the accelerations. Then this pulley is massless. This is a massless. Then what should be the force on different parts of the string? The force acting on different parts will be tension. I'll take the tension T, or say better call F. What should be the, because what is this particular pulley? It is massless, so net force on it should be 0. We applied a force of 2F. Then here it should be F and this should be F. Then this should be F. And that particular tension the string should act away from the pulley. You can see from here. It should act away from the pulley. This should be F. This should be F. Now this should be 2F. Okay, these are the forces acting. All the pulleys are massless. Huh? All the pulleys are massless. That already given. All pulleys are light. So therefore, net force on the pulley should be zero. Net force on pulley must be zero. I'll come to constraint equation. Now I'll start it. Before that, we'll write down all the equations. Huh? This will be on the block. On the block A, we'll start from on the block A. What is the force acting here? 2F and on this side F. Huh? So this should be equal to 2F minus F equal to MA. Then on the block B, the tension force acting here will be F. Here 2F and this is 2F. So this will be on the towards left will be total 4F, no? 2F plus 2F. 2F and 2F will be 2F, 4F is acting towards left. No? F is acting towards right. So the equation will be F minus 4F equal to 3M into AB. Then come for the blocks here, or this blocks here. Forces acting are 2F and 2F. Total will be 4F. So that 4F should be equal to 4F should be equal to 4M or F equal to MAC. See how many unknowns are there? Acceleration A, B, and C. We have to calculate the acceleration of the pulley P. This is what our thing which we should calculate. This acceleration of this pulley P, this has to be calculated. For that, we have this data. So this has to be taken help. Now let me start the constraint equation. The overall length of the string should remain same. So I'll start from here. So what is this length? This will be defined as xp minus xc. Then this length it will be defined as xb, because the displacement of this pulley and the block will be same. So therefore, the displacement of pulley is what? Again, xb only. The displacement of this pulley is displacement of this block. So therefore, this change in length of string should be equal to xb minus xc. Then we'll come for this. This is also very important. Displacement of this block A, should be equal to displacement of this pulley O. Okay, I agree this. So either you define XA from here or here will be same. So this length of the string also will be varying, will not be constant, will be varying, will not be constant. Agreed? So based on this now, this length of the string, we'll define this as 2 times of XB minus XA. This is little bit very important, this one. The displacement of this pulley is displacement of this block. Displacement of this pulley is displacement of block. So therefore, this length of the string will be varying. So what is this change in length of this should be equal to displacement of this pulley minus displacement of this pulley. So therefore, we should write xb minus xa. Why 2, this one, why 2? Because these two strings. Agreed? No. Okay, we have defined it. Now come for this particular string. What should be the displacement of this? The displacement of this pulley minus this pulley. Displacement of this pulley is xb. displacement of this pulley is equal to displacement of block C. So therefore, this should be equal to XB minus XC. Now come for this last one. This particular string. Displacement of this pulley is displacement of this block. Displacement of block is what we defined XC. Displacement of this pulley is what XC. So therefore, the change in length of this should be equal to XA minus XC equal to L. What is L? L should be constant, the total length of string. So what is L? This L will be from measure from here. One more thing. I think we have to measure this length also, no? XP minus XP. Last, I'll start from there. One more. What is that XP? Displacement of this length of the string also will be varying. That should be equal to displacement of pulley, this pulley, which is connected to the free end, minus displacement of this block will lead to change in length of the string. So this length of string should be equal to XP minus XB. This will be XP minus XC. I think I'll write it this in the beginning. Okay, now look at this. This length is XP minus XB. This length is XP minus XC. This length is XB minus XC. This length and this length will be XB minus XC, because this length will remain same. This length of string will be XB minus XC. This length of string will be XA minus XC. We'll add up all this. This should become equal to 2 times of XP. Here minus XB plus XB. I'll do one thing. XP. All XB terms, I'll highlight it so that addition will become easy for us. And all these are XC. Now look at this one. 2XP. XP plus XP, 2XP. Now come for this plus XA minus 2XA. Only two terms are there. Minus 2XA plus XA will be minus XA. Then come for XB. Minus XB plus XB. Plus 2XB plus XB will be 3XB. Then this will be XC minus XC minus XC minus XC minus XC. Minus 4 XC will get. I think all these are the things. They should be equal to L. Differentiating this, I'll get 2 times of AP minus 2A plus 3AB minus 4AC equal to 0. Because L will be constant. Total length of the string, L should remain constant. Total length of string indexable. So we have one equation like this. Then we'll write down. So I have other equation. So substituting all this, substituting these equations, substituting 1, 2, 3. We need acceleration of pulley PL. So this will be 2 times of AP. Acceleration of block A will become 2F minus F. This will be F equal to MA only. So acceleration of block A will be minus F by M. Let me slide down. Plus acceleration of block B will be minus F by M, because F minus 4F, this F minus 4F will be equal to AB. Acceleration of block B will be F by M. So this will be minus 3F by M minus 4. Acceleration of block C will be F by M. All set equal 0. So acceleration of this should be equal to 6F by M minus 7. Okay, this will be minus 7F by M. So acceleration of pulley, acceleration of point P will be okay, kids. I think this will be minus sign. Let me check it. This is minus F by M minus 3 minus 4F. I think this should be 8F by M. Then this should be 4F by M. Okay, this will be our answer. So the acceleration of point P, that should be calculated. This we got this one. Just writing basic constraint equation. I think we need not to do any other approach. Okay, yeah, fine. We'll take the next problem. Good evening, kids. We'll have the problems related to constraint equations. I have the two blocks, A and B. Then there's a one fixed point is there. I'll pull the block B by a force P. So it's telling like the acceleration of block B is 3 meter per second square towards right. At the instant when velocity of block B is 2 meter per second. To determine the absolute velocity of point C of the cable. Now we have to calculate that particular velocity. We'll calculate all other unknown things. First, we'll take help of the constraint equation. This will be, so there's a fixed point is there. So we have some movable pulleys are there. So if you see the displacement of the block B should be equal to displacement of this movable pulley. And this length of string will not change. This length of string will not change. This length of string will not change. The displacement of this pulley, should be equal to displacement of block A. Displacement of this pulley should be equal to displacement of block A. So here we have like this. And the displacement of block B should be equal to displacement of this pulley. Okay, I agree with this. Then, okay, how to analyze this particular condition? So here we'll use this basic reference point. I will write down only this much. XB, I write it. Then This will be XA. And let this distance be first we'll find out the unknown things. Huh? So the overall length of the string should remain constant. So the length of the string will remain constant. Then how to define this length of the string? So this part of the string again will choose from here. This length of the string will not change. This will not change. This will not change. This will not change. So what the length that will be changing is from here. This length of the string will be changing like this. Okay, fine. So this should be equal to, we'll write down the constraint equation. XB from here. So this length will be how much? Okay, the reference point, I'll show it clearly. Yeah? We'll choose this as a reference. This was the reference we have chosen. So this length of the string corresponds for XB. This will correspond for XC. This will correspond, sorry, XA. This will be XA. This will be XA. This will be XA. The change in length of these segments will correspond for displacement of block A. The change in length of these segments will correspond for displacement of block B. So this should be equal to 4XA plus 3XB should be equal to L. Altogether, because this will be 4XA, no? XA, 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 XA. Agreed? Then this should be XB, XB, and XB, 3XB. So then here 4XA, 3XB equal to L. So this will be 4VA plus 3VB equal to 0. 4AA plus 3AB equal to 0. Now differentiating this, X and XB are variable. So I have this all magnitude 3AB. So we can calculate the acceleration of block A. So what is the acceleration of block A will be 3AB by 4, 3 into 3 by 4, 9 by 4 meter per second square. This is the acceleration of block A. Now something next here. Define the absolute velocity of point C. So you see this one. When the velocity of B is 2 meters per second, it's asking to get the velocity of point C. We'll indicate here. Velocity of B is how much? 2 meters per second. We need what is the velocity of block A. And we have to calculate the velocity of block C. For that, we take help of this equation. What is the velocity of block A? 4VA is equal to 3VB. Velocity of block B is 2. So this will be 3 by 2 meters per second. So we got the velocity of block A. Now we have to calculate the velocity of point C on the string. How we can calculate velocity of point C? Again, we'll write the basic constraint equation. How to generate the constraint equation? This length of the string corresponds for XB. Let me write it here. This length of the string corresponds for XA. This will be XAC. Okay, now we'll write down the equation. XB plus XB, XA plus XA minus XAC equal to sum L. VB VB will decrease, XA will increase, or one more step. XB plus XA. So VC equal to 2VA minus VB. 2VA, VA will be how much? 2 into V by 2 minus VB will be 2. 1 meter per second. This will be our answer. Okay, now, sir, like why you are writing this negative sign? As the block B moves, this length of particular string will change. This will change. Okay, and this particular thing, XA minus XC. Okay, the negative signs. The negative signs will be if this length increases, if I take negative, the length decreases will be positive. I can choose any of the options. This particular thing, the derivative of this length increasing, I'm choosing negative. The length decreasing, I'm taking positive. Okay, agree this. So like this, we'll get the velocity of the block C, or velocity of point C on a string. We'll take the next problem. Okay, thank you, kids. Look, kids, we'll discuss one more, the wedge constraint problem. Here I have two wedges by name A, and we have the block B. The wedges are moved with a velocity v towards each other. So what is the velocity of the block B? In what direction the particular block B? The block B will move vertically up. This particular velocity is what we should calculate. The velocity of block B will be vertically up. This particular velocity of the block B has to be calculated. So a few assumptions will make it. So let R be the length of this part of the row. Let Y be the displacement. Then let X be this particular length. Let this be Y. And let this be S. Same thing. As it is symmetric, the same ideas will come. X. This will be R and this will be Y. No. So what should happen to this particular length? It has to remain constant. Okay, agree this. There's some very important small things which are very important. And the block B will move vertically up here. There's a block B. First, we'll start with the this particular triangle. Look at this triangle. I'll start with this one. From the triangle, r square equal to x square plus y square. Then, as this wedge starts moving, this pulley will undergo displacement. Then this length of string will increase. This length of string will decrease here. So is it r variable? Yes, r is variable. And this pulley will undergo displacement. The pulley will come to this position. Then x is also variable. Then the block B will ascend vertically up. Then y is also variable. So here all these three quantities are variable here. So differentiating this 2r dr by dt, 2x dx by dt, 2y dy by dt. This will be r dr by dt, y dy by dt. So this should become equal to, now what is the velocity v? V should be equal to dx by dt should be equal to v. No? This is something very important. I'm showing the red J, blue color, and the dx by dt. So the next part will be r by x dy by dt. So now the change in length of this part of the string is what v. So we'll write down here. This conditions are very important. V equal to ds by dt. Then we know L naught is equal to x. L naught equal to this is also equal to dx by dt. This is also equal to dr by dt. Yeah? How come all these things we are highlighting in this way? Why we are assuming all this as only one v? So come for this, the change in length of this part of the string is equal to velocity of the wedge. Change in length of this part of the string. How much this length will increase? How much length of this string will increase? That much length of this string will decrease. So in terms of magnitude, we'll assume like this. Then how much this length will increase? That much this length will decrease. Even dx by dt also we can write it as v. So from this will be r by x plus v. This will be v, y by x, dy by dt. dy by dt, this dy by dt, this one, dy by dt. The change in length of this segment should be equal to velocity of block. Okay, now sine theta from this triangle. What is sine theta? Sine theta equal to x by r. Then tan theta equal to x by y. We'll solve for this. So this will be, let me simplify this. This will be V sine theta, V plus V 1 by sine theta minus 1 equal to cos theta VB by sine theta, or VB is equal to V 1 minus sine theta by cos theta. Okay, this will be our answer. Huh? This will be our answer. I think this particular triangle is very important. From here is what we'll get on. So as these things are located symmetrically, as this particular wedges are located symmetrically, so what all we are discussing for the right wedge is applicable for the left wedge also. Some will ask me, sir, like you are not discussing anything here. These wedges are located symmetrically. Huh? So what all we discuss for this wedge is applicable for this particular wedge. As everything, the system is symmetric. Okay, kids? Huh? So we'll take the next problem. Hello, kids. We'll discuss some pulleys which are having some mass. Huh? A mobile pulleys, some pulleys they're having mass. Huh? In the pulley system shown, mobile pulleys A, B, C having mass m. So this having a mass m, this having a mass m, these are mass m. And what about these things? they are they are massless. Huh? These are massless. So we have to calculate the which particular acceleration of the pulleys. So what you have to calculate? Find acceleration of pulleys A, comma B and C. Okay, this is one basic equation. Huh? Okay, we'll start from here. Okay, this is some reference point. So these pulleys are fixed because this thing will become inextensible. So I shown this particular thing. You can see the pulleys which are fixed. I shown by gray color. The D and D are fixed here. So then overall length of the string, will be varying. Overall length of the string will not be constant, will be varying. Okay, I'll start from here. This is the length of the string. Will vary like this. Then it will come here. Then it will come here. You can see this is the total length of the string. It's inextensible. So this total length of string should remain constant. When we are writing equation, we are going to keep this. And what about this pulleys? This is movable, movable, and movable. First, we'll start with the tension. Let's assume the tension. I'll start from here. Let the tension be T. This is 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 T. Okay, now few contradictions will come up. Sir, how come because in pulley constraints we have seen here this is T, this is T, then this should be 2T, but I'm writing the tension T only. The reason for that is these pulleys, they're having mass, they're having the weight. I'll show that mg here. And let this be weight of this pulley. Weight of this pulley also mg. Now it's justified tension. So how come same like a T is 2T? The 2T can be balanced by T and mg. If pulleys are massless, then they will have free fall acceleration. Pulleys are having mass. Now we'll define the constraint equation. This will be xa. This length xb. This length xc. Okay, overall length of the string should remain constant. So we'll write down the constraint equation. Constraint equation. I'll start from here. I'll start from this particular string. What is the length of this particular string will be xc. This length of string will be, this will be xc. This length will be xc minus xb. This length will be xb. This length will be xa. This will be xa. 2xa will come. And this length will be xb minus xa. Equal to length L 2xc. This xb get cancelled, so we'll end up with xb plus xa equal to L. Make observation, xc plus xa will be 2xc. Minus xb plus xb will cancel out plus xb. Minus xa plus 2xa will be xa. Differentiating this, we'll get acceleration. 2ac ab plus a equal to 0. As the length of the string remains constant, you indicate like this. So the derivative of that will be 0. Okay, we have to calculate the accelerations as they're in vector form. So we'll write it in vector form. Now write down the individual equations. On the pulleys here, forces acting are mg minus 2t equal to msc. Let the acceleration of this be ac. Acceleration of this ab. Let the acceleration of this then here for this pulley b mg plus t minus 2t equal to MAB, or this will become mg minus t equal to MAB. Okay, this is one equation, this other equation, this other equation. These are the equations. We'll substitute all this in this one. So let this be equation 1, equation 2, equation 3. Let this equation 4. So put 1, 2, and 3 in 4. So acceleration AC will be mg minus 2t by n. Acceleration of B will be mg minus P by M. Acceleration of A will be solving this. This will be 2g minus 4t by M plus g minus P by M plus g minus P by M equal to 0. So this will become 4g equal to minus 4t by M minus 6t by M. T equal to 2mg by 3. This value of tension, when you substitute in all these particular blocks, no? Okay, there's a tension. So this value of tension now will substitute in this, we'll get the accelerations. So individual accelerations. The acceleration of block C will be G minus 4t by M. G minus okay, this. Here, equation 1. I should substitute all this in equation 1. Value of this tension in equation 1. Acceleration of block C equal to mg minus 2t by M. So this should be equal to G minus T by N will be 2G by 3. So this will become minus G by 3. What do you mean with minus G by 3? We assumed it downward. In fact, it will move upward. Acceleration of block B. So we assumed it acceleration of block B downward, and we got positive. In fact, it will move downward. The acceleration of block A. I'll write down all. So this will be our acceleration of block A. Acceleration of block A. Acceleration of block C. Acceleration of block B. Now, what about this interpretation? Okay, sir, you got negative. What does that mean? This will move up. This will move down. This will move down. All three cannot move down. Huh? Not possible. No. All three moving down, not possible. Let's bit some pulleys having mass. We are discussing problem. If they are massless, if the pulleys are all massless, then the tension to T and T, then they will have a free fall. Okay, kids, we'll take the next problem. Good evening, kids. We'll discuss some problem related to Pathfinder. From Pathfinder, I picked up this problem. And laws of motion chapter, LOM, Newton's laws of motion. I have the one of one end of a light inextensible cord is attached to nail A on the ceiling. So this is the ceiling is attached here, and the cord passes through frictionless hole through the bead. It will pass through like this, small bead P. Thereafter, it passes through two ideal pulleys, and finally the other end is attached to the bead. Here it will be attached here. So what actually basically you should really understand this bead, let me show like a stringer, will be easy for you. So first, actually the string will pass through it. Then it will pass, then will get attached. Some simple, you want everything. They'll pass through the pulley. There's a stringer. Once you understand, it's very easy, comfortable. See, we should understand first the diagram, the physical situation. Then okay. So here the string from here will come, will pass through the bead. Then it will pass to the pulley and will attach to the ring. Then, so what are the forces that will be acting on it? The weight mg, tension in the string, same tension. Tension should act away from the body. This one is sealing. Let's, in what possible directions it can move. It will have, the bead will have acceleration along y-axis and will have acceleration along x-axis. Now, why it should move vertically down? Because the weight mg will act, then strings will become taut. So therefore, it will have acceleration along y-axis. Then component of tensions T cos alpha, T cos beta will act and it will accelerate along x-axis. Then the equations will be along y-axis mg minus t sine beta minus t sine alpha equal to may. Along x-axis t cos alpha equal to max. Okay, fine. Huh? This is acceleration. Now we'll write the constraint equation. Let this be the y. And let this be the x. These are one basic constraint equations. We are writing it. So how the bead will try to move somewhere in a plane. So therefore, its x coordinate and the y coordinate will change. Now we'll define the length of the string. The total length of the string should remain constant. The length of the string will start from here, will be like this, will pass through this pulley and will be connected to this bead. So the overall length of the string L should be equal to, this is that beta. This is C, this is B. No, length of the string will define it. The length of the string, this part. This will be how much? This is the length. It's x component, how much it will be. So sorry, this is x. This is x. Then what should be this length? Should be x cos alpha. This is x. This will be beta. So therefore, this length should be x cos beta. This length of the string remains same, will not change. So this length will correspond for y. If you want, we'll write this length as L0. That length will remain same, will not change. Then this will be y. No. As the beat starts moving, so what should happen to y? Y will increase, x will decrease. We'll write it here. Increases, this will decrease. So differentiating this, dl by dt equal to one more step. Let me write it. X equal to cos alpha plus cos beta plus L naught plus y. Dx by dt cos alpha cos beta dl naught by dt dy by dt. So this should be 0. The overall length of the string should remain constant. The string is inextensible. Inextensible chord. Chord means here string only. So therefore, this will be constant. So based on that, dl by dt will be 0. Equal to, this will be minus Vx. Why negative sign? Because x will be decreasing. So dx by dt should be equal to minus Vx. Cos alpha, cos beta. This will be 0. No, look at this part. Already I indicated. This will remain constant. No? This should be 0. Plus dy by dt, this will be vy equal to 0. Now why this will be positive? Because the y will be increasing, so therefore this will be positive. So further, minus Ax cos alpha cos beta Ay equal to Ax is equal to y 2 zeros. Only 1 0 is there. Ax is equal to Ay by cos alpha cos beta. Now this is the equation 1. There's the equation 2. There's the equation 3. Solving 1, 2, 3, we'll get the required unknown. Somehow the diagram, student has to put more effort with the diagram here. No need of big mathematics also. Just basic this constraint equation. Okay, fine. So this will write it. Solving 1, 2, 3. We'll get the required answer. Now, what is a bead, sir? Bead, but you drew the ring. This is nothing but the bead. So we have to calculate, release this G by N. The value of N is asking. I calculated, I am having the value of 33. 2 will come. The answer will be 2. Solving 1, 2, 3. Equation 1, 2, and 3. The value of N will be 2. The acceleration of the bead immediately after release. So what is acceleration of bead? So what is that? Again, you have to take the vectors from little bit calculations are there. Try to work out. Solve equations 1, 2, 3. After solving equations 1, 2, 3, after solving equations 1, 2, 3, we'll get AX and AY. The bead will move in a plane. The bead will move in a plane. The bead will move in a plane. So the resultant acceleration of the bead is given by this one. Write down this one. It is equal to something G by N, where N equal to 2. Okay, kids, these are some problems related to constraint equation. Okay, in coming class, we'll take some other topic and some best problems. We'll discuss that one. Requesting all students to please do share and subscribe my channel. Please do share to your friends. You'll get the best of best content available. And I do come from very good institution. I worked in almost all the top institutions which are available in India. Produce best of the best ranks. With my enough experience, definitely it'll be more useful for you, the content, the purely advanced level. Each and everything in-depth explanations will be there. Anyway, you are getting benefited. Please do share to your friends who are definitely in need because all may not be in a position to afford this lakhs of rupees for the coaching. Definitely, what you share will really going to help each and everyone, and especially the persons who cannot afford the education. So, requesting everyone to be a part of digital revolution. Okay, fine. So, thank you all of you. We'll meet again. Okay, bye, kids. Take care. Yeah.